In this application, we're going to go ahead and look at that same material, the two pieces of clear material that are bonded together with a liquid clear material. We're going to look at measuring the overall thickness. And now we've gone up to the CL4 probe, which has a standoff of about 16 millimeters and then a measurement span of 4 millimeters, so it has a much bigger range. And it still has a resolution of 130 nanometers, and it should be accurate to plus or minus 300 nanometers. And it should be able to measure on slopes of plus or minus 21 degrees. And the minimum thickness of this will be about 120 microns that we should be able to measure the two faces. And if you look here, you can see that here's distance 1 and distance 2. Distance 1 is in blue and distance 2 is in the red. So if we zoom that up, you'll see that we are measuring both those faces pretty accurately. And if we come in here and we change the height of it, you'll see that the surface is following it and measuring that thickness. My fixturing is not the best here, so let me get that back in range. And let me unzoom it here. And you can see once again we're getting a very good thickness. If we want to, we can come into this application. And let me change this once again so that we can put this into the thickness mode. And let's zoom that back up. And so now we are measuring that thickness. Here again, that's the front face, and that's 175 microns is what the probe is measuring it. And once again, if we come in here and we were to look at that, and let's say that we have a constant of 151.68 for index of refraction, and let's just say that we believe that number to be about 196 microns. And so you can see just by a quick guess, I'm within probably not too far off. So you can see how easy it is to sort of fine tune this to get especially if it's a known number. So we're right about where we should be. It kind of gives you a quick feel of the application that it's working. And if we come back in here and we are to move the probe, I'm going to move the slide, and you're going to see that basically as it goes up and down across it's got a curl to it, that we're still making that measurement pretty accurately. So I believe that the white light confocal definitely can measure the front face, and with further testing I feel that we have a pretty good chance at measuring the overall thickness of this product. The second phase of this application is that we've now put on a material that has quite a bit of delamination in it, and as you can see, we are picking up just probably the front and the second surface that has been delaminated. And as I move this across, you can see that when we hit an area, it's pretty obvious when we have a correct measurement. And then we can go back over those bubbles, and you can see that the thickness goes down because it is not measuring that whole surface, right? So pretty obvious when you get into a bad surface, and then we go into a known surface where it is not delaminated. There, once again, right around that 200 micron limit.